All right, here is an introduction to how to solve rational inequalities. So remember, a rational function is like a fraction of polynomials. So that is this side. Oops, that's not a highlighter. That is this side over here. So we want to solve something like the fraction x minus 2 over x plus 1 is less than or equal to 0. And here's maybe a way to think about what we're doing here. We're looking for what x values the graph of the left-hand side is, in this case, below or on the x-axis. And that's what we're going to interpret as less than or equal to 0 as. So, I mean, if you had the graph of the rational function on the left side, this wouldn't be too hard to do. It'd be pretty easy. So what I'm going to show you is how do you do this just with algebra, so you didn't have a way to graph it. So I'll try to break it down into 5 similar steps as we did for how do you solve polynomial inequalities. So the first step that we're going to look at is try to get 0 on a side. And what we're also going to do is get a common denominator on the other side. And so in this case, if I just rewrite that inequality I'm given, it's x minus 2 over x plus 1 less than or equal to 0 already. And on the left side, I've already got the common denominator, so that's done. Number 2, if need be, you need to factor the numerator and the denominator of the rational function. So I'm looking at the x minus 2 over x plus 1. It's already all factored, so that's good too. Step 3 is the point of step 2. So why do we need to factor stuff? Well, that makes it easy to find the zeros. Remember, you're looking in the numerator for the zeros, and the vertical asymptotes. And remember, those are in the denominator. What we're going to do is we're going to plot both of those now on a number line. So this is pretty similar to the polynomial inequalities. There, you just plotted the zeros. The only extra step here that we're doing now is we're going to plot the vertical asymptotes as well. And so I'm looking at x minus 2 over x plus 1. The top tells me that the 0 is 2, and the bottom tells me that there's a vertical asymptote at negative 1. Remember, a vertical asymptote? I'm saying that that is a vertical line there that goes to the x-axis at negative 1 that the graph never crosses. So your function, or whatever you want to think of it as, is undefined there. Step 4, here's my picture of this stuff on a number line. Notice too, and maybe I'll start with step 4 here too. Maybe notice when you plot those zeros and those x-intercepts, so that's my beautiful colored number line above, that splits the number line into, in my case, 1, 2, 3 different parts. So you'll get more parts if you have more zeros and more vertical asymptotes. But we split the number line into these subintervals. Now what we'll do is we'll pick a test point in each subinterval, we'll plug it into our rational function, and we'll just see what the overall sign is. So is it positive or is it negative? So I've copy-pasted my number line here, and I've picked some test points in each interval. It does not matter which test point you pick. If you want to choose, instead of x equals negative 2, if for whatever reason you feel like choosing x equals negative 5, that's fine. You do you. Anyway, you take those, and what we're going to do is we're going to plug each test point into the function. So I'm doing this kind of all at once in each subinterval. You could do this one at a time. But when I do that, I plug in negative 2 on the left here for the x's that I see. And then in the middle, I'm plugging in 0. And on the right side, I'm plugging in 3. Remember, I'm doing this simultaneously at once just for presentation purposes. So if I simplify all of those, I don't care what number it is. So like, for instance, yes, I know that's negative 4. I just care that it's negative. And yes, sure, that's negative 1. That's cool. I just care that it's negative. So I'm just keeping track of what sign it is. Now I'm going to simplify these. Negative divided by negative is positive. Negative divided by positive is negative still, and positive divided by positive is positive. So we are determining the sign of that rational function in each one of these subintervals here. Now what we'll do is we'll use those signs that we just obtained in order to determine which subintervals actually solve your inequality. And as a rule of thumb, you will always use a parenthesis when you're talking about interval notation. Always use a parenthesis whenever a vertical asymptote is one of your endpoints. That's because, again, that fraction, that's a rational function is undefined at the vertical asymptote, so you need to have a parenthesis. So I'm looking at x minus 2 plus 1 is less than or equal to 0. That was the original. And now what we'll do is we'll interpret that right side again. If you're less than or equal to 0, that means you want the minus signs that we found in step 4. And since it's or equal to, it's okay if it is 0. So you'll use a bracket whenever you're dealing with a 0 as one of the endpoints of your interval. So here's my picture with the signs included here. And what do I want? I want the minus sign. So that's the middle blue interval. And so how will I talk about that interval? Well, I'm going to use a minus 1 on the left. And that's my left endpoint. And remember to use a parentheses there because that's your VA. And you'll use 2, that's your right endpoint for the blue interval. And we'll use a bracket there because that's where a 0 is. And we said it's okay if it is a 0. And so we just solved maybe our first rational inequality. In the next video, we'll do maybe a slightly more complicated example.